Hello community! Welcome to the most watched part of how to instruct fine-tune your large language model. After the amazing success of part 1 and part 2, now part 3. So here we are. Now we have here a look at the prompt, Stanford ALPACA prompt. So we are taking here exactly this prompt. Remember, this is step 1 like I showed you. Now we do it one by one. So we say, yeah, let's execute this. Have a look at it. So we say, okay, you're asked to come up with 20 diverse task instruction. Now create step 1, 20 instruction. And as I told you, there are some requirements. Try not to repeat the verb. The language should be diverse. The type of instruction should be diverse. The ChatGPT or GPT language model should be able to complete the instruction. It will be in English. The instruction should be 1 to 2 sentences long. You should generate an appropriate input to the instruction. Not all instructions require input, as exactly as I showed you in my last video. What is the highest peak in the world does not necessarily provide a specific context. In this case, we simply put no input in the input field. And the input should be appropriate, an appropriate response to the instruction in the input. Make sure the output is less than 100 words. So, ChatGPT generate a list of 20 tasks. And here ChatGPT, or then in the case of Stanford University, they had a slight variation, but this is exactly how it is done. Now the system comes back. Generate a short story with the theme of betrayal. So you have the input. A man finds out his best friend is stealing from him. Output. As he confronted his friend, he learned the truth. He had been betrayed not just in business, but in their friendship too. So here you have exactly the same. You have an input, you have an output, and you have the instruction generate a short story with the theme of betrayal. Those is our to form from my last video. Now, next example. Classify the following text as positive or negative sentiment. Input, I love this movie so much. Output, positive sentiment. You see, it's always the same repeating pattern, a to form. Next example, provide a recipe for some vegan lasagna. Oh, Jesus. So since here the object vegan lasagna is already defined, we don't need an input that defines here our object. So we say, okay, output. This is the output. Next topic. Summarize the main idea of the news article about politics. You see? Input, the bill was introduced. Yes, yes, yes. Output, the Senate introduced a bill focused on climate change. That would be so nice. So you see now here we can generate this. Hey, this is nice. 8. Generate a poem about the ocean. So this is our instruction. Since we have here the ocean as an object here, as the topic, we do not need a specific input. And so the output now generated here by ChatGPT, the March 23rd version, by the way, is now this poem. And this is the input data that goes now into the fine-tuning of our LLM. So it understands exactly if I have this output and I have this instruction set, these are related, and he learns all the connected interlinks of here this semantic context. What else do we have? Okay, you see, sometimes it goes wrong, no problem. You can sort it out if it has not the length and it has not the structure. I'll show you in a second how we do this. Generate a haiku about autumn. This is our instruction. The input, we know it's autumn, it's a haiku. The output, leaves falling gently, colors of gold and red glow, autumn's beauty shows. Okay, so now I've shown you here. This is the first step here, Stanford ALPACA prompt text here. Beautiful. Now you might ask, okay, so what were the 175 human-defined tasks? So let's take here this one. So we go here, we put in this one. Let's see what he does. Let's see here. This was the original human input. So we have an ID. This is the seed task 12, the human written task number 12. Then we have here the instruction. The instruction is explain humans behavior. We have here a code name, explain behavior for internal reasons. And then we have here the instances. And like I showed you in my last video, we have two fields. We have an input field and we have an output field. So here we go. The input field is the behavior that is given in the instruction, explain humans behavior. And now in the input field, the behavior is characterized or defined as crying, tears. The output now is, there could be many reasons why a person might cry, could be feeling sad, scared, angry, frustrated, yes, yes, yes. So you see, these are the human written examples. Now look, if I put this here just into ChatGPT and I say nothing, I just put it in. Look what he does. He comes up with a modification. Can you provide, the instruction is now, can you provide an explanation for why people behave in certain ways? Look, the original human way was explain human behavior. And now it's a much nicer way. And then, of course, we have our instances. And here we have the first field is our input field. And this is the same, crying. And then we have the output field. Human behavior can be complex and is influenced by a variety of factors, such as emotion, experiences, and personality. This is so much nicer than this human written sentence here. And this is the power here of GPT-4 or ChatGPT, I don't know, whatever, March 23. This is why you need one alpha GPT that has been trained on tens of millions of dollars on more than 1,000 GPUs. You have to have one alpha intelligence, and then you can copy and extract and modify and whatever you do in combinatorial things. So this is the beauty. But anyway, I wanted to show you this was the human input as I showed you in my last video. And now more or less, yes, why not? Let's go into the code. So just want to show you, where are we? We are here in Stanford ALPACA. No, thank you, thank you, thank you. Stanford ALPACA. An instruction following llama model. They call it an instruction following. I call it a self-instruction, fine-tuning, whatever. And there we have the code for generating the data and the code for fine-tuning the model. So let's have a look how they generate the data. That you see that what I explained to you last time is exactly what they did. License data JSON. Yeah, JSON was exactly what we have. In a second, where is it? Here, generate instruction. Sorry, this one. So here we go in. And what I want to show you, here we start. Generate instruction following data. Our instruction or self-instruction generated data for fine-tuning. So here we go. What do we need? We need a path to our seed task that I just showed you, the JSON file in long. Then we need an OpenAI API. And there we need a model. We go with the text DaVinci 003. So this is where you have to have your credit card ready. The number of prompt instruction is 3. Remember, we have instruction, input, output given as a structure of our instruction data set. You can have the temperature, you can have the number of CPUs available, whatever. This is great. So what happens now? Now we load simply here from our file that I just showed you, seed task path. Where is it? Here. Seed task JSON long. Here we now load here our data. ID, name, breakfast, instruction, everything you know and that you love. Here you have the instances, input and output. Here we are. So back to the data. Where is it? Here. So what do we do? We have now here our seed instruction data. We have exactly, we take now the instruction, we take the input, you remember this is a field of the instances of the instruction, And we take the second field of the instances, and this is the output. So we just read here the 175 human-created seed instruction data to create our own data set. Yes. Later we want to calculate the similarity, but this I'll show you later. So first we tokenize all the seed instruction. Remember, yes, we have a tokenizer also here. Yes, generation, yippee, for our machine instruction, and it is so easy. We have here, we take our instruction for all seed instruction data and all instruction for the machine created data. What a surprise. And then, yes, sample, here we go. This here is now, and here it's graded. Now let's look at this one in detail. So we are sampling only because we are beginning the seed task. So we have a random sample, and then comes the beauty, and now we encode our prompt from our prompt instruction. And then we just append it together, and then we have our data set. And then we go here to OpenAI, to the utilities by OpenAI. And OpenAI will create, as I just showed you here, some diverse tasks. So where are we? Here we're. And you can say here the temperature, you can define everything you know with OpenAI API. You can set a lot of parameters, top P, top N, whatever you like. And then you just say from the utilities OpenAI completion, and it generates here all the data that you need. But the most important thing, again, I lost it here. Here is it. Here, prompt. Encode our prompt. So encode prompt. Where is it? Let's have a look at encode prompt. Here we are. Define encode prompt. So we encode multiple prompt instruction into a single string. We have to bring now our instruction into our data pipeline, our input data pipeline for fine-tuning. So you're not gonna believe it, but it is the same. So for enumerate prompt instruction 175, here we have now the task of instruction, the task of input, and the task of output. Who would have guessed that? And then if we want to combine it in a single string, you're not gonna believe it, here exactly instruction, input, output are combined into a single string, and we return a prompt that has now a single string prompt with all our 3 information fields included. We have the perfect Q form. And then, you can have here the post-process GPT response after GPT-3 or GPT-4, whatever you have generated the data. You have to clean it. You have to make sure that it has a certain length. It's not too short or long. Then you have here, as I told you last time, you can filter out certain images that you do not like to have, video, audio, flowchart, diagram. You make it cleaner. You can take care here about the punctuation, but this is not so important. The most important part, as I showed you here, we started here, and we were now able here to encode our prompt, to generate the prompt, to generate now from OpenAI, exactly like I showed you here, I don't know, 50,000 similar descriptions. And then we have our data set. What do you do then? Just wanted to show you. You want to have that from those 50,000 data sets, they are not all similar. Like, today is a beautiful day. Today is a nice day. Today is a very good day. You know, you want to compute the similarity. Hey, you remember BERT? We compute the similarity of sentences. Remember? We construct a vector embedding and compute the cosine similarity of our vector in the vector spaces. Yes, this is what's happening here. You compute the similarity with the pre-tokenized instruction, and all those that are too close, you just filter them out. You want to have a diverse data set. Beautiful. This is it. This was here. I wanted to show you here the code implementation. So you go to Stanford ALPACA, generate the instruction, the Python file. This is it. Now you know how to generate your code. You have your model card. We had a look at this. The prompt, yes, of course, the prompt. I showed you here the execution in our ChatGPT. You know this now too. The seed task I showed you, requirements, yes, of course, if you want to do it, we need a NumPy. We need here something that we compare the similarity. You need here, of course, your special token, meaning your credit card information for OpenAI. We're operating with transformers. We're operating here in Pytorch. We have a sentence piece tokenization. We have a certain version of tokenizer, and we have W and B. So everything you know, everything you love is here. Now you understand it. Utilities, anything I lost? Yeah, OpenAI decoding arguments. You have the temperature, you have the float, you have the optional sequences. This is OpenAI specific. You can read in OpenAI exactly what they want from you. The decoding arguments by OpenAI in the form that they wanted. It is a beautiful explanation. So you can go and really, really do the same job as Stanford University for about $600. What else? Training. Training. We want to fine tune our system, our LLM, because up until now, we just created a data set. My goodness, I almost forgot the most important part. Fine tune our LLM with a self-instruct dataset. Let me start by the main core of this example. This is it. This is the main core. It is always the same. Look, we have a model. We have from the Hugging Face transformer an auto model for causal language model from a pre-trained Hugging Face model. And there we give it the model name and path, and then the model and a tokenizer. And the tokenizers again. From the Hugging Face transformer, we use an auto tokenizer, has been pre-trained. These are our parameter for this. So you see, model tokenizer as always. Then you can take care about the padding, the size here with the pads in the tokenizer. You have, if you have a llama, you have some special token, forget about it. And then we have here the data module. Now this is one of the most interesting things right now, but let me skip it for now and say here, look, we use now the Hugging Face trainer class. Hugging Face trainer class is defined for us. We just have to input the model, the tokenizer, and I just showed you here. Where is it? Where is it? Here. This is our model. This is our tokenizer. And then, of course, we need the data. So we have here the Hugging Face trainer class with the model, the tokenizer, and the training arguments. And, of course, our data module. And then you just say trainer.train. As always in my last 100 videos, this is not a command to fine-tune your LLM. Then you can save the state. You can save the model to a Hugging Face hub that everybody else can use it with your name. And this is it. So the only question left is now here our data module. And here we have a function make supervised data module. Oh, beautiful. And our input is, of course, a tokenizer and the data arguments. So let's have a look at this. Line 185. Let's go there. So here we are. Make supervised data module. Maybe even a little bit bigger. So what we do, we make a data set and a data collator for some supervised fine-tuning. Well, of course. So what we have here a supervised data set with a tokenizer and our path, and a data collator supervised data set. Now, data collator, you know, we used this a lot of. What comes out here is now a dictionary where we have our training data set. Well, we have no evaluation data set for the moment, and then we have our data collator. So this is exactly what we need for the fine-tuning. So we have here two functions, supervised dataset and data collator. What a coincidence that we have here the class definition for the data collator for supervised dataset. What it does, it collates examples for supervised fine-tuning. And if you remember my other videos, this is just about the maximum length, about the padding that's happening, the pad sequence. So more or less, I leave this up to you. This just takes care about the perfect padding, that everything has the same length, everything is homogeneous, there are no short and long sequences. Please, this is for you. Now, the really interesting thing here is our supervised dataset with our dataset that we just created. So this is now our dataset for supervised instruction fine-tuning. So beautiful. Now what we need a tokenizer, because we have to translate our human words into some numerical vector representation or a tensor representation. So we take one from the Hugging Face transformer from the pre-trained tokenizer. Beautiful. If I remember correctly. No, I don't know what Stanford is using. Sorry. So super logging warning. We load the data path. Warning prompt. You know what? As I showed you, why not use here this task description? So I tell you something. Why not let ChatGPT work for us in explaining a certain piece of code? So let's see. Get item. Is this really the last one? No. Where am I? Get item. Yeah, it's the last one. Beautiful. So, you see, you do not need me anymore because I just ask here ChatGPT, explain this class of supervised dataset where we input our dataset. So this is our data set for supervised fine-tuning. We have here our tokenizer, our pre-trained tokenizer from Hugging Face. We have our data path. We have here the warning. Beautiful. And then I think the most important thing is here the prompt input and the non-input. This is if we have an input field or not an input field. Okay, I get it. I don't care if we do not have an input. Yes, beautiful. So what we have sources and we have targets. And warning. And then we have data that pre-process sources, targets, tokenizer. So I think the most important, most interesting field is sources, targets, and data dictionary. And from the dictionary, we have here our input IDs and our label is the classical one, and then we return everything. Beautiful. So let's see what he comes up with. I want here two variables, prompt input and prompt no input, are assigned values for the prompt dictionary. A list comprehension is used to create a list of sources. Each element in the list is created by formatting the prompt input or prompt no input string with values from each example dictionary in the list data dictionary list, depending on whether the input key in the dictionary is empty or not. So easy to understand. Another list comprehension is used to create a list of targets. Each element in the list is created by concatenating the value of the output key in each example dictionary with a specific EOS token attribute of the tokenizer object. Okay, and then we have a preprocess function is called with the sources, with the targets, our tokenizer arguments. And this function tokenizes the input and target text using the provided tokenizer. And here is it happening. And returns a dictionary containing the resulting input and label tensors that we need. So here is the magic happening. Beautiful. You see, sometimes it's nice. Even the free ChatGPT version of March 23, you just input here, just to explain this Pytorch code for step by step. And he's really explaining it if we have here the data set. Now, this is so nice. The only thing maybe I'm interested, the tokenizer transformer pre-trained tokenizer, exactly what we use, but otherwise, isn't this a beautiful explanation of what's going on here? And there you have it. We went through the complete code of Stanford ALPACA. I showed you how to build your self-instruct dataset. We then together went through the code of instruct fine-tuning your language model. And now you know all the secrets how to instruct, fine-tune your own large language model. I hope you enjoyed it.